Okay. Okay.
Okay, here's our project. Our project is investment strategy AI trader for foreign exchange. Our group member is, my name is Hanlu Wang, and my group member is Zhaomen Wang. Okay, next. Here's our test goal. We want to implement a foreign exchange AI trader system, which using neural network and machine learning techniques to learn from big data. And also it can forecast, predict the foreign exchange. This system also have these features, which is low delay real-time system and built-in risk control mechanism. We want this system can be used by the traders to help them predict the future foreign exchange trends. Okay, next. Here's our literature survey. We use a model called long short-term memory, LSTM, which is a type of recurrent neural network capable of learning order dependence in sequence prediction problems. This model uses some gates to control if the model will memorize the states before. So this is very suitable for the prediction learning. And also, yes, this model introduced the mechanism of gates in order to eliminate the vanishing gradient and the exploding gradient. We mainly uses the paper below to help us understanding this model. And the next. Here's the data sets we use. The most important data set is the exchange rate, which is the exchange rate of US dollar to other countries' currency. For 10 years, we use 10 years data for the learning, and for prediction, the users will input a month data to predict 7 days data. And the other data sets are help for the learning. The first is gross domestic product, the GDP, which reflects a country's economic growth. So this is tightly related to the exchange rate. And also the interest rate, because high interest rates can absorb the money to flow into the country. So the interest rate also related to the exchange rate. And the CPI, the Customer Price Index, which shows the inflation rates of a national currency. And also the ratio of exports to imports. This shows the international trade balance. These 4 data are helpful for the learning process, which can increase the accuracy of the learning. So we use these 4 data to also as an input of the learning process. These 4 data are also the 10 years of data. And next. We build this project in Python and based on the PyTorch. And also we do the learning process on Google Colab. Yeah, next. Here's a model we use. As we introduced before, the input is 30 days of data. And each days of data includes these dimensions. The first is timestamp and also the exchange rate of US dollar to other countries' currency, and also GDP, interest rate, CPI, and rate of export to import. The output is the 10 days of future exchange rate. Okay, and the Zhaomen will introduce you the process.
Okay, as you can see in the pictures, in the left columns, we just use those aforementioned 5 kind of data as input to make the prediction. We use this last day's data of those 5 kind of data as input to this LSTM model. And you can see in this figure is the training process that the model is trying to like find the trends of the currency rate, exchange rate, and yes, and in the right most pictures, you can see that is the prediction result of our models and trying to give the result of the predicted result of the next coming 7 days, and our after like our model after like 2,500 epoch of training, our model have achieved a relatively high accuracy with the MSE loss of 0.02, and you can see those pictures. And the leftmost pictures is the training process as mentioned before, and in this in the process of evaluation, we just test 100 predictions and get the result. And you can see the right line is the predicted result, and the green curve is the ground truth. And you can see the MSE of those 100 data is just fluctuating at 0.02, which is relatively high accuracy. But later, after the training process, we still want to optimize on our models, and through studying the literatures, we decide to modify the 2 parameters in our model, that is the number of layers, which indicate the numbers of layers, yes, and the hidden state, which means and the hidden size, which indicate the hidden states of each layer in our model. And yes, and in the process, like change the number of layers, actually we achieved stacked LSTM. A stacked LSTM architectures can be defined as an LSTM model consisting of multiple LSTM layers. The LSTM layers above provide the sequency output rather than the individual values output to the LSTM layers below. And this figure shows the architecture of stacked LSTM models, which has 2 kind of layers, 2 LSTM layers. Yes, and why? Why doing this? In addition of layers increase, the level of abstraction of the improved data over the time is also increased, which means we can gain higher level abstraction of the input data. And a stacked LSTM model also improved the training efficiency and accuracy, like by adding a network deeps, because in generally in deep learning field, the network highs, the more the network's deep, the more sophisticated or structure it have, it can like again the more features of the input data and have a better result. And yes, and for the hidden set in our model, we also want to increase the hidden state in each layer, which means we increase the hidden size. And the larger hidden set is the model's complexity may also increase, and the set effect, which is the overfitting phenomenon, may also occur. But the improvement of a certain extent can also improve the model's accuracy. And nowadays, generally speaking, there's no rules to like better define exactly how many hidden state we should have. But so this is really depends on the experience, and more neuron means that we can project our data into a higher dimension space and learn more parameters from those connections between the neurons, and more and in generally, like there's if we have more training examples, we add more hidden unit, which is the hidden size. We increase hidden size. So as I said, there's no specific rule, but in our model, we set it to 356, and we want to evaluate our new models. And from there, you can see the improved result that we finally achieved an MSE of 0.006, which is 3 times better than before. And in this table, you can see the left column is the ground truth, and the right column is the predicted result. Is pretty close. And what I want to emphasize is you can see these figures, especially those 3 points in the upper figures, our improved model, and you can see those models can really good at reflecting the trend of the data. It's really close to the ground truth, the real world data, that the trend is like increase and decrease, like there's a peak. And however, in the last model, in the phototype model, its performance is not that good enough, and not better, because it's actually it's just increased. You can see those 3 points is just increase, so it cannot very accurate reflect the trend of data. And yes, so I think in our optimization, our model is really improved and get better result. And in the end, I want to introduce some our applications about this project, because we believe that our application may face to some person without a technical background, which is the trader or like the investor in the foreign exchange market or institute. They don't have like a background of a program like of coding, machine learning. So we just add and graphic user interface to our applications, and trying to help the users to really use our project to do the predict to help them. And I want to show you our applications. Yes, and from here you can see that there is this is a graphic user interface of our applications, and in here you can select the types of the prediction you want to do. For example, like you want to do Australia dollars to US dollar, you want to predict the exchange rate of those kind of two currency, and you can choose the first one, and then you'll click this button to upload and data, which is used for the models used to like do the prediction. And for example, I just upload the CSV view of the exchange rate and interest rate, and I just click open, and you can wait. Yes, and it gave you the prediction result of output of the models, which is the next coming like 7 days. Yes, this is a prediction result. You can see the figure and the data. Yes, yeah, I think that's all. Yes, thank you for your attention. Thank you.
Thank you.